Good morning, everybody. Well, who's ready for vectors? All right, so that is 9.4. We're going to be looking at vectors, and this is a topic that you're going to see in other classes. You're going to see this in physics, you're going to see it in some of your engineering stuff, and you're also going to see it if you go all the way through the calculus series, you're going to see it probably in calculus 3. Okay, so let's get started. So vector, actually, in the movie Despicable Me, there's a character called the Vector, and he actually defines it correctly. So he is a vector, so he is a quantity that has both magnitude and direction. So magnitude, that is just a real mathy way to say length. So it has a length and it has a direction. So you know how far you're supposed to go and you know in what direction to head. Okay, so let's look at them a little bit graphically. So vector v is drawn below. So this is your vector v. And vectors, when you write them, they usually have this little half arrow thing on top. If it's typed out, a lot of times it will be typed out in boldface. So that means you have a vector. So here's our given vector. And part A, they want us to draw to V. So the 2, that just is going to double the length of your vector V. It's going to point in the exact same direction, but it's just going to be twice as long, and so it needs to have like the same slope to it. So this one's over 4 up 6. So over 4 up 6. And then again, and I gave you a graph that's not big enough, so you're just going to have to kind of guesstimate. Let's just say right about there. So that would be 2v. So that's all it does. The number in front just either makes it grow or shrinks it down if it was some sort of a fraction smaller than 1. Okay, so part B, let's see what happens if there's a negative on it. So the negative means it's going to be in the opposite direction. So instead of going up into quadrant 1, we're going to go down into quadrant 3. So over 4 down 6. Oops, I totally missed, but that's all right. You get the idea. So that's a negative v. So negative just flips the direction in the opposite way. Okay, example 2. Use the vectors in the figure to graph the vector sum of u, v, and w. So they have them all separated here. So all you need to do is we're going to start with vector u, and we're going to plot it in the same exact position. So over 1, 2, 3, up 1, 2, 3, 4. And over 1, down 2 for the actual vector. So there's vector u. So now we're going to go to the next vector, vector v, and we're going to move him, and it's still going to have the same length, but we're going to attach it to the finish of vector u. So it has a length of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we're just going to slide a vector v and attach it to vector u. And then the same thing with the next vector in the sum, vector w. We're going to attach him to the end of vector v. So that was over 2 up 5. There's vector w. So the vector sum, it's going to be the vector that goes from the very, very beginning all the way to the very, very end. So that would be u plus v plus w. So you can look at it this way, like these, the blue vectors, u, v, and w, these would be like the directions you would tell somebody like how to walk to your house or how to drive to school. And the green vector, the vector sum, is if you, instead of having to make all these turns, if you could fly from point A all the way to where you're trying to get to, that would be the vector sum. Okay, so vectors, they have a lot of definitions and properties that we need to talk about because we're going to end up using them quite a bit. Okay, so the unit vector, that's a vector whose length is 1, just like the unit circle has a radius of 1. And the length and the magnitude of a vector, just in general, is denoted as like a double-sided absolute value bar. A scalar is just something multiplied to a vector, like that 2. That was in example 1. The 2, that's a scalar. Okay, algebraic vector. This is where you can kind of write it as a somewhat as a point, but instead of having the parentheses, it has these angled brackets on it. So if you see this, they're talking about a vector. So algebraic vectors, they have these things called components. So the A, the first number in there, that's the horizontal. So it's telling you how far over the vector is going to the right or to the left. And then the B is the vertical. It's saying how far it's going up or down. A position vector, if you have a vector between points P and Q and they have these coordinates, then a position vector is found by taking the x coordinates and subtracting, and same thing for the y's. And what this does is it moves the vector and it slides it down and it connects it to the origin, which is pretty useful if you're trying to find the distance or excuse me, trying to find the angle of what it's where it's going. So it's usually better if it's connected to the origin. And then standard unit vectors, these are just the vectors going along either the x-axis or the y-axis. So it would be vector I, and it's got this little thing on there, it's a hat. So I hat is equal to 1, 0, and j hat equals 0, 1. So if you're looking at a graph, I would be going straight out to the right by 1, and then j is going straight up by 1. So these are your standard unit vectors in the x direction, and then j is going in the y. Okay. So I will let you guys look over these properties. They're kind of pretty straightforward on what to do if you add vectors or subtract them or multiply by a scalar. And then just for the blanks, the horizontal component of v, so vector v is all the way up here. That would be a1, since it's next to the I. And the vertical component, or the one going up and down, is what's connected to the j, or the second number in the algebraic. And so that would be B1. All right, in this next video, we will start looking at examples with vectors.